Hello everyone. Today's lecture topic is pure rolling, and at the end of the video you'll have a clear understanding of pure rolling if you follow this lecture properly. Please try to sit along with a pen and a paper and try to take short notes in between so that you'll have a clear understanding of this topic. Let's start. So first I'll tell what pure rolling is. So rolling means there will not be any slipping between one particular body and the ground. You can have many circular objects, like let's say there is a ring, there is a disc, there may be a sphere. It can have motion on the ground. So in this rolling, we'll consider that that particular body, whatever is moving over the ground, it is not sliding or it is not skidding. So in the terms of physics, I'll tell that whenever a circular body is moving or having this pure rolling, between the body and the ground, at the point of contact, there will not be any slipping, or there will not be any slipping phenomena or skidding phenomena. So basically we can tell that the relative motion between the body and the ground at the point of contact will be zero. So rolling is an example of the combined motion we have discussed in the last lecture. Combined motion. But it is a special kind of combined motion where the circular object is not slipping over any particular surface. That means, let's say, this is a circular body. It may be a ring, it may be a sphere, it may be a disc also. Let's say it is having radius of r. And the center of mass, it is moving with velocity of v. And at the same time, it is rotating with the angular velocity of omega. Maybe you can assume that one car is moving on the road. Its wheel is having this kind of pure rolling if it is not skidding on the road. So we can divide this into two motion. One is purely translational motion where all points on this particular body is moving with the same velocity of v towards right, plus pure rotational motion, omega, and the radius is r, pure rotational motion. This is translational motion, this is pure rotational motion. So here we'll be interested about the velocity of the point of contact. Point of contact means the point this body is touching the ground, that is the point of contact. So you can tell that each and every time when the time is passing, this point of contact is changing, because at this point of time this point is having one point of contact. After some point of time the contact will be different, so maybe this point will be touching the ground, so that time that will be the point of contact. But we'll be discussing about, or we'll be interested about, the motion of all these point of contact or the velocity of all these point of contacts. So let's say at this instant this is the point of contact. So it is divided into two motions. One is translational motion and another is rotational motion. So translational motion, what is the velocity of the point of contact? Point of contact, POC, I'll write. So from the translational motion we can tell that the point of contact velocity is v in this direction, v, because all of the points are moving in the right direction with velocity of v. But see, in rotational motion, this point is having velocity in this direction. The velocity magnitude is r omega. The top point is having velocity in this direction, r omega. Because you have studied that v is equal to omega into r when a particular body is having purely rotational motion. What is the value of the velocity at distance r? And it is of course the perpendicular to the line joining the center and the point of contact, or any point. The velocity is perpendicular to the line joining the center and that particular point. That is r omega. That is the value of the velocity due to the rotational motion. So see, this point of contact velocity is r omega, but in the left direction. But due to translation motion, it is having v velocity in the right direction. Or you can tell it is positive x, negative x. Okay, that's okay. So total velocity of this particular point or point of contact will be the summation of these two velocities, or we can tell that vector summation of these two velocities. So this vector form we can write that the velocity is v into I. In vector form we can write that this velocity is r omega, but this is in the negative direction, so it is r omega into minus I. So total velocity of this point of contact is becoming v minus r omega into I. Now the rolling tells that the point of contact should not have any slipping, or the point of contact should not be slipping with respect to the ground. If the ground is fixed, the velocity of the ground is 0, and velocity of the point of contact POC is this one we are getting by this. So what is the condition of pure rolling? That this point of contact at that instant will not have any relative velocity with respect to the ground. Now if the ground is fixed, what is the relative velocity with respect to the ground? This is the relative velocity, that should be 0. So basically this should be equal to r omega, that should be equal to 0 only. This minus 0 is 0 basically. So v should be equal to r into omega. That is the condition of pure rolling. That is how the vector sum of the two velocities that is getting generated, one is due to translation motion, another is getting generated due to rotational motion, that sum will be equal to 0 at the point of contact. Now we are considering that the center is moving with constant velocity. So it is also an example of non-accelerated pure rolling. So first we will be discussing the non-accelerated pure rolling, then we will come to the topic of accelerated pure rolling. Non-accelerated pure rolling means the particular body is moving with constant velocity. So what is accelerated pure rolling? Accelerated pure rolling is, let's say one car is right now having the velocity 0. Then the car driver starts the car and it starts to move. It is starting to move means it is having some acceleration. In that condition, is it skidding or not? If it is skidding, then it is not a pure rolling. If it is not skidding, then it is a pure rolling. So that we will discuss later. First we will talk about the non-accelerated pure rolling. So this is the condition. So I have told that when a body is moving with velocity v and rotational velocity omega and having the radius of r, the condition for the pure rolling, if it is rolling on the static ground, v should be equal to r into omega, where v is the velocity of the center of mass and r is the radius and omega is the angular velocity. Now if I tell that it is moving with velocity v and rotational velocity omega and radius is r, but the ground is not static, ground is also moving. Let's say it is moving with velocity of v by 2 in the right direction. So this is a problem number 1 we will discuss first to understand the concept in a better way. Now I am telling that this disc is having pure rolling over this moving ground, which is moving with velocity v by 2 in the right direction. What will be the value of the omega if this disc is having pure rolling over this ground? So how to do it? The velocity of the body, all of the points on the body is moving with velocity v. So this is the first translation motion we have segregated. Then we'll tell that it is moving with angular velocity of omega, radius is r. So this point of contact is having velocity in this direction, r omega. It is v. Now what is the net velocity of the point of contact? v minus r omega into I. So that is the velocity of the point of contact. Now, in the last example of understanding the pure rolling, we have considered that the ground is not moving, but here ground is moving with what velocity? V by 2 in the x direction, so V by 2 I. So condition is relative velocity of the point of contact with respect to the ground should be 0. So that is VPOC minus VG should be 0. We just put those values. V minus R omega I minus V by 2I, that should be equal to 0. So basically, we are getting V minus R omega should be equal to V by 2. R omega is equal to V by 2, V by 2 will come that side, omega is equal to V by 2R. So that is our answer. If the circular body is moving with angular velocity of V by 2R, then it will have a pure rolling with respect to the ground. Now we consider some different phenomena. What is called slipping? If this is understood, we'll again go to the same. So in the topic of pure rolling, it is very necessary to understand what if it is not pure rolling. So that means you have to understand what is slipping. What is the meaning of slipping? Slipping means this particular body at the point of contact is having some relative velocity with respect to the ground. Slipping means for this body, if it is moving with velocity v and rotating with angular velocity of omega and its radius is r, this point of contact is having some velocity which is not equal to the velocity of the ground. That is called slipping. So it can slip forward or it can slip backward also. So we'll try to see it. Let's say this body is moving with velocity v and angular velocity of omega. So at this point, due to the rotational motion, the velocity is coming in this direction, omega into r, and due to the translational motion, the velocity is becoming v in this direction. Or slipping can happen if v is not equal to omega r. If it is moving on a static ground, then the slipping can happen. So v can be greater than omega r, or v can be less than omega r. If v is greater than omega r, this body will move with higher velocity than the value of the omega into r. So you can think the example of when a brake is applied suddenly on a car, what happens? So wheel stops rotating, but it has some velocity in the forward direction. So what will happen? It will skid. It will skid over the road. So that is called forward slipping. If v is less than omega r, that is called backward slipping. But you can think about that example of the car when it is starting. Let's say it is started with very high angular velocity, or the tires are moving with very high angular velocity. You have seen in F1 racing, or you have seen in maybe Fast and Furious movie, a car is starting with a very high angular velocity. Its wheels are rotating with very high angular velocity, but it's still not achieved any translational velocity, or maybe it is very less compared to the movement of the wheel. So it will happen, what will happen? It will skid at the same place because it is not having higher translational velocity to move forward. So it will skid at the same place. So that is called backward slipping. So in the first example, we have discussed about the point of contact velocity only. But right now, we will try to figure out what will be the velocity at each of the point present in the circumference of that particular circular body. Let's say we have derived for this particular point what is going to be the velocity in order to have pure rolling. So let's say v is equal to r omega. So that means the circular body is having non-accelerated pure rolling. Now, if I tell that at any angular position, what will be the total velocity of that particular point? Let's say I am telling that. So from here we will start to measure the angles. So we'll try to, or we'll join the center and the point of contact at that instant, and we'll try to measure the angle from here clockwise. So let's say at any random angular position, that is theta, from the line joining the center and the point of contact is theta. So this motion can be divided into two motions. One is translational motion pure, and another is purely rotational motion. So due to translational motion, all of these points are having velocity in the right direction, that is v. So this point will have the velocity v in the right direction. But due to the rotational motion it is having, what is going to be the velocity? R into omega, of course, but that velocity will have a certain direction. What is the direction? The line joining between these 2 points, that means this point and the center, this velocity due to the pure rotation is going to be r omega, but in this direction. R omega, but in this direction. So at any random point P, the total velocity of this point Vp will be the vector summation of these two velocities. And first one is V into I. Another one is, we have to calculate what is that. See, we'll just draw one line. This x-axis is the y-axis. We'll draw one line which is parallel to the y-axis. See, this is theta, means this is also theta. So what is the angle between them? V and r omega. So basically, the total velocity of the particular point P is going to be the vector sum of these two velocities. Just we have to find out this angle, and we can do the vector sum, and we'll be able to find out what is the velocity. So if this is theta, that means this is 90 degree minus theta. This is 90 degree minus theta plus this is 90 degree. So we can tell that 90 degree minus theta, 90 degree minus theta, and this is 90 degree. So the angle between V and r omega is becoming 90 degree minus theta plus 90 degree. So it is, angle is becoming 180 degree minus theta. So we can write that, and this is becoming then theta. So we can write that r omega cos theta minus I. This we are dividing two components. One is this component, that is r omega cos theta in the negative y-axis minus I, plus another one is r omega sin theta in the y-axis, r omega sin theta j. So we can write that v minus r omega cos theta of I plus r omega sin theta into j. But as I told, it is having pure rolling, then v is equal to r omega. So you can easily write in terms of v only, all the velocities. We can write that v minus v cos theta into I plus v sin theta into j. That is the total velocity of the particular point. Now see, this is a very general velocity of any particular point. If the value of theta is 0, then this random point P will represent the point of contact. So if you put 0, see, you will get 0. Total velocity is becoming 0. So point of contact is velocity is becoming 0, and the ground velocity is also 0. So the relative velocity between the point of contact, between the body and the ground, is becoming 0 only. what will happen if theta is 180 degree? Theta is 180 degree means from here you are calculating the value of theta. So theta 180 degree means we are talking about the topmost point, this point. So what is going to be the velocity of that particular point? Vp will try to find out. Just put there. Theta equal to cos 180, theta equal to 180, we will put v minus v cos 180, that means this is becoming 2v I plus v of sin 180 means 0. See, we are getting the velocity of that point, this point, topmost point is 2 into v. We can find out what is going to be the velocity if theta is equal to 90 degree. That means we are talking about this point. So we can divide this entire circular body into 4 parts. We will be discussing about the velocities of these 4 points. 1, 2, 3, 4. This point velocity we have got as 2 into v, top point. What is going to be the velocity of this point? That means we have to put theta equal to 90 degree. So theta 90 degree means we are talking about this point. So theta equal to 90 degree will put, then the value of particular point is going to be vi, because cos theta is 0, plus v into j. So we are getting vi plus vj, and their mod value is root over of v square plus v square, that means root over of 2 into v. We are getting total velocity, mod value of the velocity. So top point mod value is 2 into v. We are getting. So this point also will get the total velocity as root 2v only. This point, if we put theta equal to 90 plus 90 plus 90 to 70 degree, we will be getting the value of this velocity at the particular point is root over of 2v only. So you can think about a particular image where this velocity is 2v in the right direction. This velocity is root 2v, but in which direction? 45 degree angle, because x component and y component both are same, so net velocity will be in this direction, root 2 into v. So this velocity also will become in this direction, that is root 2 into v. So see, you can draw an analogy that for a pure rolling body, this is the point of contact having velocity 0. So entire body is rotating with respect to this point of contact that instant. So at that instant, the entire body is rotating with respect to the point of contact only. We'll try to draw a bigger image for the better understanding. So let's say this is the entire body. The point of contact velocity is 0 because it is having pure rolling, 0 let's say. This point is moving with velocity of 2v in the right direction. This point and this point both are moving with velocity of root 2 into v. But for this point, it is moving in this direction, making an angle 45 degree with the x-axis, root 2 into v. This point is also moving with this velocity, because if you put theta equal to 27 degree, you will be getting the value of the velocity, but in this direction, making angle 45 degree with the x-axis, root 2 into v. So other point also you can find out what will be the velocity, but for the just now I am just finding out the velocities of these 4 points only. So you can think that the entire body is rotating for that particular instant with respect to the point of contact only. So if we join all these points, so this point if we join with the point of contact, the net velocity will be perpendicular to the point of contact. This also, if we join this point and the point of contact, you will be able to understand that this particular point is that instant rotating with respect to this point of contact. If we join this point, it's perpendicular to it. So that means the easy way of finding out velocity at any point is to draw one line from that point to the point of contact, and the net velocity will be perpendicular to it. Total velocity will be perpendicular to that particular line. So you can tell that this point of contact for the pure rolling is instantaneous axis of rotation, or IAOR. Point of contact is IAOR, or instantaneous axis of rotation. So if I tell you what will be the total velocity at theta equal to 30 degree. Theta equal to 30 degree means you will be interested about, let's say, this point. What will be the total velocity of this point? So that means this point from the line joining the center and the point of contact, this point. So you can easily draw a line to the point of contact from that particular point, and you can tell that the total velocity will be perpendicular to the particular line you have drawn from that point to the point of contact. So it will be in this direction. Total velocity. And you can multiply with omega with that particular distance, you can find out the velocity. So for this top point, what is the distance between this top point and the point of contact? Is 2r. So net velocity is 2r into omega. This 2 into r into omega. But it's pure rolling, so r omega is equal to v. So 2v is the velocity. That is what we have got. So if we talk about this point, let's say this point, what we have already found out, this point is having 270 degree from here. So this is basically making 90 degree. So this distance, how much? This is r, this is also r. So this distance is root 2 into r. So direction is perpendicular to the particular line, this direction. But what is the magnitude of the velocity? The magnitude is this distance root 2r, you multiply it with omega. So you will get root 2 into v only. This is the velocity. That is how you will calculate the velocity at any point. Just calculate the distance and multiply with omega, you will get the velocity. But the distance, please remember, the distance is from the particular point to the point of contact. That is the distance. You have to multiply with omega, you will get the velocity magnitude, and the velocity direction, total velocity direction will be perpendicular to the particular line. Now we have already got at any random theta, velocity is v minus v of cos theta I plus v of sin theta into j. Now what is the total velocity or the velocity magnitude? Root over of this square plus this square, 1 minus cos theta thus square plus v sin theta square. So we can get the magnitude of the particular point, what is the velocity. So v will come out of the root, and we can write 2 minus cos theta plus cos square theta plus sin square theta. So cos square theta plus sin square theta value is 1. So we can write that 1 plus 1 is 2, 2 minus 2 cos theta. Then we can also write that 2 will take common, 1 minus cos theta, 1 minus cos theta is 2 sin square theta by 2. So we'll get 2v sin theta by 2. That is the magnitude of the velocity at any particular point, which is having angular distance theta from the line joining the center and the point of contact. That is the value of the velocity. So that way also you can find out what is the value of the velocity at any angular position from the point of contact. So if I tell that theta value is 180 degree, 180 degree means I am talking about the top point. If you put that, you will get the value of that particular point. The velocity is 2v sin 180 by 2, that is 90. So 2v you are getting. At this point, the value of theta is 90 degree from the point of contact, angular position. So at theta equal to 90 degree, you'll put the value of 90 degree. What is the value of the velocity? 2v into sine 90 by 2, that is 45. 1 by root 2, so root 2 into v. That's what we have got. Root 2 into v. In case of pure rolling. Pure rolling means if v equal to r omega on a static ground. If you put theta equal to 0, that means you are talking basically about the point of contact. So you are getting the magnitude of the velocity to be 0 only. Now let's say again a circular object is having radius of r, it is moving with velocity v and it is rotating with angular velocity of omega. So how much distance the center will cover in one complete rotation? This center, after let's say one complete rotation, it has reached this point. So what will be the distance it will cover through one rotation? You can think about, so here also velocity is v only, r omega only, so omega into r, that is okay. So one complete rotation, let's say it is having from here to here, what will be the distance between the center, between these 2 points, between these 2 instants, let's say. So you can think that one where is wrapped around a particular circle or a particular circular body, and whenever it is rotating, it is leaving, it is getting unwrapped from here to here. So that is how we will calculate what is the distance the center will travel. So if it starts unwrapping from here, one particular wire which is wrapped around it just for one complete rotation, so how much wire will be unwrapped, or what will be the distance or what will be the length of the wire that will be unwrapped while it is rotating by 2 pi angle, that means one complete rotation. So if it is unwrapping from here to here by one rotation, then this value is nothing but the perimeter of that particular circular object. What is the perimeter of that object? 2 into pi into r. That is going to be the distance of the center of mass from here to here. How to prove that? Omega is, you know, omega is v by r, or v equal to r omega, we are getting omega is equal to v by r. So for one complete rotation, that means 2 pi angle, how much time it will take? It will take time, let's say delta t, that is 2 pi by omega. Angular distance it needs to cover by the angular velocity, that is the time it will take to complete the one rotation. Now, by that time it will complete one rotation, its center will advance by how much distance? V into delta t, or that will be going in the right direction with velocity of v through that time delta t. So what is v? V is v only, delta t is value is 2 pi by omega, and from the value of the omega, if we put the value of omega, that is v by r, we will get that v into 2 pi, v by r, we are getting 2 pi r. But you can remember it through the unwrap also. Unwrapping of a string over the circular body. While it is rotating, it is unwrapping the string, and the distance it will cover is 2 pi r. That is the perimeter. That is what we have proved here. Now we'll talk about what will be the locus of any point at circumference. That means we will talk about a general point, that is P, which is located at angular position of theta from the point of contact. Let's say VP. What will be the locus of it while it will rotate by 2 pi angle. So let's say from here to here it will rotate by 2 pi angle. So that means it is completing one rotation only from here to here. So what will be the locus of the particular point? So basically from here, if it starts rolling, the point will again come back. This same point will again come back as a point of contact after one complete rotation only. But it will move in this kind of path because it is rotating, and it will move in this kind of path. Sorry. Like this. So after getting rotated by angle 180 degree, it will be coming at the topmost point. So here, this is the position. It will have this kind of path, and this path is called a cycloid. This will again come back as a point of contact after having one rotation, while this circular body is rotated by pi angle, that is 180 degree or half the rotation. This point will reach here after having half rotation. This point will reach at the top. So here at this point, the velocity of point of contact is 0. So after some point, it will have the velocity of 2v, and after some point when it will again come back as a point of contact, that time the velocity will be 0. So its velocity will vary from 0 to 2v, again to 0, again it will go to 2v when it will again rotate. But we got a general expression that the magnitude of the velocity at any angular position, it is 2v sine theta by 2. So what will be the distance we cover from here to here, because it is having variable velocity. So when this particular point is just starting to roll or starting to complete one complete rotation, it is starting from velocity 0. Its velocity is increasing. When it is angular position 180 degree, its velocity is maximum, then again its velocity is 0. So it is a variable velocity. So what will be the distance of this particular path it will cover in one rotation? That we have to find out. The velocity, the general velocity is this one. So we know theta is equal to omega into t. If the angular velocity is omega, at any time, random time, if it is t, then theta is equal to omega into t. At t equal to 0, the angle is 0. At t equal to, let's say, 2 pi by omega, that is the time taken to complete one rotation. If you put that, you will get the theta equal to 2 pi. Basically, it is completing one rotation. So what will be the net distance covered? So for a variable velocity, you know the distance covered, or s, is v dt, integration of that. We'll put the value of v. What is the value of v? We got 2v of sine theta by 2. Theta will put as omega into t, and dt will put. So from 0, how much time it will take to complete one rotation? 2 pi by omega, because it is one rotation, it is covering 2 pi angle. So to cover 2 pi angle, it will take 2 pi by omega time. So 2 pi by omega we will put, that is the distance it will cover in one rotation. So that is 2v, we will just do the integration. Integration of sine omega t by 2 is minus cos omega t by 2 by the exponent of t, that is omega by 2, from 0 to 2 pi by omega. We put the value. Cos of omega into 2 pi by omega by 2, that is cos pi, that is 1, minus 1, so it is 1, minus of minus 1, so it is becoming 2. So 2 into 2 into 2, that is 8, v by omega, but V we know that V equal to R omega, so V by omega is R, so 8 into R. That is the distance covered by one point at the circumference in one rotation. It will cover 8 R distance. The distance is the length of this particular path. Because it is having different velocity or at different point of time, that means it is having variable velocity with time. So there is no other way other than integration to find out what is the length of this particular path, because it is having variable velocity. That is why. So let's discuss very interesting problem of the topic of non-accelerated pure rolling. So this is a ground which is static ground. On top of this ground there are 4 identical discs are kept having radius of capital R, let's say, and in between one plate is kept which is pulled with velocity of V in the left direction, and on the top of all these discs there is a plate which is pulled to the right with velocity of 2V. Then what will be the angular velocity ratio for the top 2 discs with respect to the bottom 2 discs? So top 2 discs will rotate with same angular velocity as omega 1, bottom 2 discs will rotate with angular velocity of omega 2. You have to find out what is the value of the omega 1 by omega 2 and what value of that you have to find out. And it is given that all of these discs are having pure rolling. How to solve that particular problem? Let's try that together. So it is having pure rolling. Let's say we'll discuss about, first we'll talk about the bottom discs. 2 discs. So both these discs are having similar angular velocity because both are having the same condition of the top point and the bottom point. So both of these discs are having the same angular velocity. Let's say it is moving with angular velocity of omega 2. So omega 2 is the angular velocity of the bottom discs. Top point, one plate is being pulled in the left direction, so V. So what will be the translational velocity for that particular 2 discs? Let's say it is V2, let's say. So what is the relation between V omega 2 and V2? See, what we know for the pure rolling case, the top point is having velocity of 2 into V. So 2V sine theta by 2, that is the common velocity at any point of the circumference. For the top point, we will put the value of theta is equal to 1 degree, we will get the value of velocity as 2 into V. But that V is the value of the velocity of the center of mass. Also, the center of velocity is V2. So we will get that. Right now, what is the topmost point velocity? That is V. Center of mass velocity or the center velocity is V2. V2. That is sine of 180 degree by 2. So we are getting that V2 is basically becoming V by 2. So what is the value of omega for the bottom discs? We are getting. It is having pure rolling. So pure rolling means V2 is basically omega 2 into R. V is basically omega. So for this case, translational velocity is V2 angular velocity is omega 2, so v2 equal to omega 2 into r, that is the condition to satisfy. So value of the omega 2 is becoming v by, so we'll get that value of the angular velocity for the bottom two discs are v by 2r, that is we got. We'll keep that in our disposal. Now we'll try to find out for the top disc. See, for the top disc, the top point is moving with velocity of 2v in the right direction. Bottom point is moving with velocity of v because it is pulled by that top plate in the topmost point. For the bottommost point, it is pulled in the leftward direction with velocity of v. So certainly it will rotate clockwise, of course, with, let's say, angular velocity of omega 1, and we do not know what is the velocity of the center of mass. So let's assume that center of mass velocity is v1 towards the right. So for the bottommost point, to have the pure rolling condition satisfied, what should be the value of the velocity? See, it is having, due to the rotation, it is having velocity of omega into r in this direction. Due to the translation velocity, it is having v1 velocity in this direction. But it is given that the velocity itself is v in the leftward direction. So value of omega 1 into r must be greater than the v1. So omega 1 r minus v1, that is the velocity of that particular point of contact, that is actually equal to the v, so that it doesn't have any relative velocity with respect to the its ground. So for this disc, this is its ground, reference ground. So this is v that we got. Again, for the topmost point, what is the value of the velocity? For the topmost point, what is the value of velocity? v1 plus omega 1 into r, that is the topmost point velocity, but that is given as 2v. So we'll write that v1 plus omega 1 into r, that is 2v. So from these two equations, we'll get the what is the value of omega 1. If we add these two equations, we'll get that 2 of omega 1 into r, that is ultimately becoming 3v. So omega 1 we are getting 3v by 2r, that is our angular velocity for the top two discs. So what is the ratio? We can easily find out what is the ratio, omega 1 by omega 2, that is 3v by 2r by v by 2r, so it is becoming 3. So 3 is our answer. This is the mod value, of course, because those are rotating in opposite direction. These top two discs are rotating in the clockwise direction, and bottom two discs are rotating in the anti-clockwise direction. So basically, if this mod is not given, so omega 1 by omega 2 will be minus 3 because those are in opposite sense. But we have given the mod, so the answer is 3 only. So I hope this non-accelerated pure rolling part is clear. So in the next part of this pure rolling video, we will talk about the accelerated pure rolling, and we will solve many problems on the topic of pure rolling. Thanks for watching.
Now I am giving you one problem that was given in JEE Advanced 2012, paper 2. You can attempt this problem. This problem requires the concept of pure rolling.